Now in first order reaction, there are the sometimes some different cases, different types of questions are asked. Instead of concentration, they gives volume, pressure, or sometimes the angle of rotation. So over there we use some different formula for calculating the rate constant. The formula, the base of the formula is going to be the same initial upon the final, that is after time t, but the formula changes according to the different case. So we have the determination of rate constant for the different cases of first order reaction. Sometime in question they gives the volume of a reagent. So the first one, let's see the first point. The first case, when volume of a reagent in a volumetric analysis is given. For example, suppose if I am doing some certain analysis like H2O2 and the analysis of H2O2, and during that we are adding KMnO4. So volume of KMnO4 is given. Or I can say during some analysis some acid is added during the titration or something, or some bases are added. If the volume of those reagent which is added during the volumetric analysis is given, then what formula we use? So here suppose V0 is the volume of reagent used at time t, at time is equal to 0. Vt and V infinity is the volume used at infinite time. Generally these three things are given in a numerical, that is V0 will be given. V0, that is when the time is equal to 0, then the values will be given after 10 minutes, 20 minutes, 30 minutes, 40 minutes. So if 10, 20, 30, 40, whatever the values are given will be considered as a Vt. And finally they give the value that is V infinity. Infinity is that instead of time, in time section there will be the infinity. So we consider as a volume at infinite time. So in that case, for rate constant we have a formula. Therefore rate constant K is equal to, if such type of questions are asked, so rate constant, that is K is equal to, we use a formula 2.303 upon T log to the base 10, instead of A0 upon AT, it's in our volume. So we have a formula V infinity minus V0 upon V infinity minus Vt. So this is the main formula you have to consider. Now in this formula also they give the two different types of cases. Sometimes they will give you V infinity, V0, Vt, all three quantities are given. Sometimes what happens, they don't give V infinity, or sometimes what happens, the V0 is not given, that is initial value is not given. So we have two more cases in the same part. So case 1, if V0 is not given, suppose it means in a numerical the value of volume at time 0 is not given. So in such case I can use a formula K is equal to, the formula will become 2.303 upon T. If V0 is not given, then in a formula we will not consider V0. So the formula will be V infinity upon V infinity minus Vt. Case 2, if V infinity is not given, if V infinity is not given, then simply remove V infinity from the formula. So you will get a new formula, that is log to the base 10. From here V infinity is removed, so we will get V0 upon Vt. So we will use this formula, that is V0 upon Vt. So we have three formulas. If all three quantities are given, that is in the volume at infinite time, volume at 0 time, and the volume at time t, that is in between, we will use this formula. If V0 is not given, that is the volume at time t is equal to 0, then the formula is going to be this. And if the V infinity is not given, then we will use this formula. Now the second one, if the pressure of a gaseous reaction is given, This is the second, the question may be asked on this. Now the pressure of gaseous reaction is given. Now say in this what happens. Suppose there is a container, this container is containing some reactant. The reactant is also gas. The product is also in a gaseous state. So when there is a if in the initial case, when the time is equal to 0, I will say there is only reactant inside the container. So the pressure exerted by the pressure exerted inside the container will be equal to nothing but the pressure of a reactant only. But with time what happens, the reactant get converted into product, and here the product forming is also in a gaseous state only. So since the product is also in a gaseous state, so slowly the reactant concentration will goes on decreasing, and the product the reactant pressure will goes on decreasing, and the product pressure will goes on increasing. So when the time is equal to 0, the pressure inside will be equal to the pressure of reactant only. But after time t, the total pressure will be equal to nothing but the pressure of the reactant as well as the pressure of product. So in such case, we have another formula when we have the total pressure. Here they gave you the initial pressure and they give the pressure after time t, but that pressure after time t is not for the reactant, it is total pressure they give. So from that total pressure, you have to first calculate the pressure of reactant, because we have a formula A naught upon AT. So here I can use a formula P naught upon PT, but that PT is the pressure of reactant only. So suppose after time t, they are saying that pressure is 50 atmosphere, that out of 50 atmosphere, some pressure will be of reactant and some will be of product. So you have to determine that how much reactant pressure and how much product pressure. So PT will be only the pressure of reactant. Now how to solve such type of, what formula we will use in such case. So here I can say, let P naught is the pressure of reactant at time is equal to 0. This will, if the P naught is given, means it is purely a pressure of reactant, because time is equal to 0 means there is a no product, the reaction has not started, so no product. Then once the reaction start, some of the reactant will start getting converted into product, and if some of the reactants are getting converted into product, means I can say the reactant pressure goes on decreasing. So how much? Suppose X is the amount of the pressure which has been decreased due to the decrease in the amount of reactant. So I can say P naught. Suppose X is removed, so P naught minus X. What is X? This is the decrease in the pressure after time t. So it is going to be P naught minus X is the pressure of reactant after time t, which P naught minus X, I'm just writing it as a PT, small t it is. So the formula is going to be 2.303 upon T log to the base 10. A naught upon AT, instead of A naught upon AT, we will have P naught upon PT. But that PT is about P naught minus X. The P naught will be given to you, but X is not given. So first we have to determine, we have to replace X from here. So for a time being, suppose if I am considering K is equal to, what will be the formula? 2.303 upon T log to the base 10 P naught upon PT, that is P naught minus X. So as I said, X will be not given. X is any term which we have just assumed. It will not be given in a question. So first we have to try to replace this X from here. Now suppose there is a reaction. The reaction is like A gives B plus C. A is also in a gaseous state, B is also in a gaseous state, C is also in a gaseous state. Now, initial pressure, that is the pressure when the time is equal to 0. So it is going to be P naught for the reactant. There is a no product, so these values are going to be 0. Then pressure after time t, pressure after time t. After time t, as I said, some of the reactant has been consumed. So the pressure of the reactant has decreases by X. So it's a P naught minus X. And if P naught minus X is a decrease, X is a decrease in pressure, then I can say this will be the increase, this Why it is decreased? Because so much amount of product has been formed. So X will be the pressure of B as well as the X will be the pressure of C. Now I have to just replace X from, we are just doing everything just to replace this X from here. So we will have a form, just let us calculate total pressure. So total pressure will be equal to, total pressure I am representing it by capital letter T. It is equal to total pressure, that is, it is going to be the pressure of reactant as well as the pressure of product. In a numerical they give the value of PT, that is the total pressure. So it is P naught minus X plus X plus X. XX will get cancelled. So ultimately we will get PT is equal to P naught plus X. So here I can say X is equal to PT minus P naught. So in a formula we are going to write this P naught minus X here. Instead of X I will write PT minus P naught. So here I can say therefore P naught minus X is equal to P naught minus P naught minus X. It is PT and this minus will become P naught. So ultimately it will changes to P naught minus PT. So if there is only two products has been formed, then this formula will changes to 2.303 upon T log to the base 10. I can say it's a P naught upon, instead of P naught minus X, what we will have now, 2P naught minus PT. Suppose if there is a one more product is forming, instead of two products, suppose if there is a three product, then what will happen if there is a three product? So let's, for a time being, suppose there is a third product is also formed, D. So it is also going to be 0 and this is going to be X. Now the formula will change depending on one more product is forming, so your total pressure will be changed. So what will be now? New pressure. So total pressure will be, new total pressure will be that is PT. It will be equal to, again the sum of all, that is P naught minus X plus the product pressure, that is X plus X plus X. So it will be total equal to P naught, XX will get cancelled, plus 2X PT. So I can say that X is equal to PT minus P naught upon 2. So instead of X now I will substitute PT minus P naught. So this P naught minus X will be equal to now, P naught minus X will be equal to now P naught minus PT minus P naught upon 2. Let open the bracket, so it will become 2P naught minus PT plus P naught whole upon 2. It will changes, or this value will become, it is equal to, I can say that 2P naught plus P naught is 3P naught minus PT upon 2. So now in a formula, suppose if there are the three products has been formed, then what will be the formula? It is going to be 2.303 upon T log to the base 10 P naught upon 3P naught minus PT, and then 2 will come to the numerator. So it will become 2P naught upon 2P naught, 3P naught minus PT. If one more component is given, then again you have to calculate the P naught minus X. And similarly, if the pressure is given, so for whatever the number of component is forming, on the basis of that we can make a formula if the pressure is given for the pressure based questions. But if for the volume we have this simple formula, V naught, Vt and V infinity. V naught is not given, then remove V naught from the main formula. If V infinity is not given, then remove V infinity from the formula and you will get the final formula. So these are the two different, two more cases where the rate constant can be asked.